This is Unit 1, the Alphabet and Grammar of Geometry. Preview Video 1.4, Brain in Hand Problem Solving, Part 1. Sit tall. Ready? Inhale. Deep breath, hold. Birthday candle. Close your eyes just for a few seconds. Take a deep breath. Today is one of the most important lessons of the entire year. If you think of this carefully, it's going to be totally revolutionizing the way you understand learning in a math class. Make sure you get the date, time, and location that you are watching this, as well as a parent or guardian sign off. So let me give you just a 10-second history. Starting about 10 years ago. So first off, there's some vocabulary. Let's talk about neuron, frontal cortex, digital immigrant, digital native, hypertext, skimming, linear reading. A couple words about the vocabulary there. I am a digital immigrant. In other words, I am old enough to actually have lived before the internet and digital technology and personal computers. I grew up in what's called an analog world. And at some point in my life, in my very late teens, early college years, began using the most basic word processor / the nascent of a computer called an Apple IIe. A couple of years into college, started using the very first Mac computer. My mom was a Motorola employee, so she was her company was providing the chips, if you will, to the Apple company, so she was able to get her hands on one of the first Macs. So I come from a different growing up season than you, as what you are called digital natives. And around 2010, 11, 12, I noticed a change in my students. I'd be doing very basic problems on the board, drawing a triangle. Let's say this is 60 degrees, 50 degrees, and unknown. And I'd be working with students at the board, and I would get this really strange look in their face. And even though this was a very basic problem, I would get the I don't know or I don't get it. And I was like, what do you mean you don't get it? Triangles, 3 angles of a triangle add up to 180. And I noticed when I would be talking, my hands would be on the board saying triangles. Notice my fingers. 3 angles, notice my fingers, add up to 180. Therefore, you add 50 and 60, take it away from 180. Or I get something very simple like this. I would draw an angle, and I would say the angle is 60 degrees, and it's being bisected. Those little hatch marks mean bisected, and I would ask a student, what's the measure of this angle? And I would literally get crickets. What's going on here? And then I would take a student's hand and we go 60 cut in half. Notice what I'm doing with the fingers. What's the measure of this little angle? And all of a sudden I would get this reaction. Oh, it's 30. And I'm like, what is going on there? When a student looked at it, they didn't get it. But when we started physically tracing on the board, I get this instantaneous reaction of understanding. And I'm like, I do the fingers on the board and paper automatically, but my students were increasingly not utilizing their fingers in order to process visual spatial information. They weren't tracing, they weren't underlining, they weren't highlighting, they weren't drawing. Therefore, their connection to the math seemed to be delayed. So I did my master's thesis. I was so motivated. 2010, to 2013, I did my Master's of Education, and my thesis project was how is digital technology changing the wiring of young people's brains, and what are some key things I need to do as a teacher to compensate for how brains are changing. That's what my master's project was on. So I'm very motivated about this particular project. You also need to know, before becoming a teacher, I was an occupational therapist, which is a health degree. So I do have a background in understanding at least the basics of neurology. And my master's thesis came down to 5 key thoughts and compensations. Key thought number 1, your fingers, particularly these fingers, which are called the eye fingers, are physically connected through neurology to what's called the frontal cortex. The frontal cortex is the front part of your brain, and that is the part of the brain which processes conscious critical thinking skills versus unconscious things like heart rate and breathing, which is down here in the brainstem. So your fingers are directly connected to a portion of your frontal cortex. In other words, your brain takes in information not just through your eyeballs, not just through your ears, but also through your fingers. Key thought number 2, technology and the use of technology is changing how people's brains are wiring as you grow up. It's physically changing. And why is that? Because in your childhood, you were spending more time typing on a keyboard than you did physically writing. The act of physical writing connects more neurons than tapping on a keyboard. That's important. Because if you can force yourself to write more, physically write more, it actually helps brain cells rewire more. Also, growing up, most of you spent more time clicking on screens rather than coloring on physical papers. Also, growing up, you spend more time tapping on screens and doing digital models, if you will, on a screen versus actually getting your hands physically on tangible models of the real world. All of that is changing how your brain processes information. This is key. Thought number 3. If you didn't know this, this is revolutionary. Screen reading is different than print reading. When your eyeballs hit a computer screen or a tablet screen, it has a tendency to wander. That's why web designers know they have about 2.5 seconds when they design a website to grab someone's attention to get them to want to stay. They have less than 5 seconds, and that is because the minute your eyeballs hit a screen, they tend to wander. Versus when your eyeballs are on paper or a book, your eyeballs tend to travel according to how we read, which is what's called linear reading, left to right. That's important. If you have a choice to read information on a physical book versus a screen, you should always default to the physical book or physical paper. Key thought number 4, the more you increase the use of your fingertips in processing information, tracing, gesturing, underlining, okay, making pretend models with your hands or actual physical models, touching, okay, increase finger usage increases brain function. That frontal cortex. Key thought number 4. Most importantly, key thought number 5. There is a particular place in your brain called Fingernosis. And this is documented in this research that I have footnoted down here as part of my master's thesis, just so you know I'm not totally off my rocker. Your brain, fingers, your brain is connected specifically to what are called your eye fingers. It's connected to a place in your brain called the left angular gyrus. It's right behind your ear. That portion of your brain processes mathematical spatial relationships. Mathematical spatial relationships that do not process through your eyeballs. In other words, there's aspects of mathematics that are only properly processed in your brain when accessed through your fingertips, not strictly through your eyeballs. That's my attempt at an eyeball with eyelashes. That's very important you understand that. That's called the left angular gyrus. If you're super curious, you and your parents can look up this study. All this to say, you're going to hear some very key phrases in my class over and over and over again. And I corral all this particular mindset of thinking under the catchphrase of your brain is in your hand. Quite literally, your brain is connected to your hand. So what are some things you're going to do differently in this class? When you don't know what to do, what can you do? 5 things. I expect you to memorize them, my friends. I'm going to test you on these at some point. 5 things. Number 1, and the most important, you will read with 3 body parts 3 times, always. 3 body parts means your finger is going to be on the paper. Your lips move when you read any text, and your eyeballs are obviously on the text. Most of you grow up reading only with 1 body part, your eyeballs. No more. Your finger on the paper, lips moving, finger on the text. So 3 times, you first read with 3 body parts. Second time, you read again and underline or filter or highlight keywords, especially numbers. Then you read again and you take the words and you draw a diagram, label the diagram, make a list of given information that's not on the diagram, and as you account for information, you cross it out. This little symbol here, kind of crass, but it communicates no naked diagrams. That means diagrams, when you see them, you should be tracing, shading, labeling, marking, physically interacting with your diagram. All diagrams get dressed up. What can you do when you don't know what to do? Review your reference booklet. Key question, you ask yourself, well, what can I do? Not what should you do? And you take the problem and like a sponge, you squeeze out every piece of information you think you might know before you actually understand. When you write equations, equations have 2 sides with an equal sign. So for example, if I ask you for the slope equation and you write it like this, rise over run, and that's all you write, and I tell you write the slope equation, I will mark you half off. Why? Because the slope equation is slope equals rise over run. If I ask you for the equation, an equation has 2 sides with an equal sign. I'm also going to model, when you write an equation, you're going to learn to write a things first equation before you do the algebra. Last but not least, once you write equations out, you do what I call circle, plug, chug. You do a physically circling, picking up, circling or boxing or underlining numbers, but you physically interact with your numbers. You plug them in to set equation, and chug is just my way of get it done. It rhymes, kind of. Let's do some together. We're going to start super simple, and then we'll get more complex. Ready? Step number 1. Put your finger right there. Lips moving. You're reading aloud. You read aloud. Ready? Go, read. Number 2, underline keywords or highlight. We have a distance. FE is 6. F to D is 18. Finding. We account for it on the diagram. This is where colors come in handy. I like to color code things. I recommend you get colors handy. And when you do colors, let me just show you a recommendation. If you hold them in your fingers like this, I call it a claw, you can take the lid off and put it back in super quick and switch between colors a lot faster than picking it off your desk. Just note. So we start labeling. D to E is 6. Notice I cross it out. F to D is 18. We want to find D to E. I'd like you to physically trace. Trace, please. Finger on the diagram. Trace 18. Trace 6. Trace the unknown. You have 5 seconds. Okay, you should have felt it that 18 is bigger, so it's going to be 18 minus 6, of course. And you should have gotten 12. Again, reading 3 parts with 3 body parts. Finger on the paper, lips moving, read it out loud. Go. Highlight, underline. We have F to D is 15. F to E is 11. GE is 18. Find GD. Let's start tracing. F to E, I'm going to bracket that. 12, cross it out. Do not track with your eyeballs. You're tracking with your fingers by tracing. F to E. Excuse me. I mislabeled that because I didn't read it out loud earlier when I told you guys to read it out loud. Be very careful with this. F to D, because I told you to read it out loud, but I didn't. I am modeling what you should not do. Is 15, which we have also right down here. Cross it out. F to E is okay, it says 11, should be 12. So I go like this, that's 12. GE, which is the whole from here to here, trace it, is 18. We're being asked to find, in the midst of this, G all the way to D. Five seconds. Okay, if you traced, if this whole thing is 15 and that's 12, You should have been able to figure that this little piece right here is 3. And then if I want the entire segment from here to here is 18. Here to here is 3. So 18 plus 3, 21. Trace, 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 trace. Here's an example of a things first equation. We're going to trace and sweep this angle here. So I'd like you to trace and sweep that like a rainbow. Just trace it. Trace it like a rainbow. As you trace it, it's half a circle, so you know immediately that that's 180. If you have colors, switch colors. Then we have this angle is 115. I'm switching colors again to green. From here to here is unknown. This is your things first equation. Angle plus angle equals 180. That's a thing equation. I'm talking about things. I'm talking about angles. Now I do circle, plug, chug. I circle, I plug it in. This angle, I sweep it. I don't know it. It's B equals 180. Chug means just do the math. Now you're back to an algebra problem. So B is going to equal 180 minus 115. Try to do your math longhand, please. It's good for the brain. B equals 65. Here's another example. I'd like you to just trace all the way around, because this is not a straight angle. So what are our thing equation is going to be like this, all the way around equals, I've got 3 angles, B plus this angle plus this angle equals all the way around. That's my thing equation. You always start with the thing equation. Now, some of you are going to be very tempted to skip that step. Don't do it. On a test, I'm actually going to have a spot for the word thing equation. I expect you to write something in there, even if it is extremely rudimentary, like this. Now I do circle, plug, jug. The B is unknown. I have an angle, I circle it. I have at this angle, I sweep it. And by tracing the red, I figure out that that is 360. Now we solve. So we're going to do 360 minus 282. Once again, please resist the temptation to use a calculator for simple addition, subtraction, multiplication, division. Always try to train yourself to do stuff longhand. it's better for the brain. It connects more brain cells. So we're borrowing, and we are borrowing. That's 8, and that's 7. So our angle B is going to equal 78 degrees. We're going to do a couple more problems. This one I'd like you to do on your own using the methods I just showed you. Ready? Pause the video. Welcome back. Students, you should be switching to a red pen, please, and you're correcting your work now. Step number 1, you should have done a thing equation, which looks something like this. And if you can color code it, it's even better. The thing equation would look something like this. Angle plus angle equals, you could either say like a rainbow if you want, or you could have put in 180 there. Then we circle, plug, chug. For your algebra, we circle, we plug it in, and we're going to end up with 3x plus 19. Circle, 5x plus 1 equals 180. Collect like terms. I like to underline my variables, double underline my numbers. To never get happy with just the variable. Geometry rarely stops with the variable. You should have, because I asked you to find all your angle measures, you should have plugged that variable back in. And so therefore 3 times 20, 60 plus 19, that would make this 79 degrees. And that would make this 101. Which when you add it up, adds up to 180. Physically, it works. Last couple problems, we're going to review a perimeter versus area. I want you to think of a rectangle like a backyard. When you do perimeter, it's like the fence around the backyard. And I always want you to be in the habit of physically tracing around the perimeter. So when I talk about perimeter, you should be in the habit of walking your pencil around, and I'd like you to stick a little arrow. The little arrow says I went around. You could trace it that way, or if you're left-handed, it might feel more comfortable tracing this direction. But either way, you trace around and put a little arrow to say, this way, I went around. Now, when you have perimeter, you have lengths and widths. When you go around, you end up doing something like this. Length plus width plus length plus width. That's for a rectangle. You might commonly know perimeter as this, as far as an equation is 2 lengths plus 2 widths. I personally will not use that equation. And the reason is students get tripped up with distributing those 2's. I personally like what's called the expanded version, where I just simply say length plus width plus length plus width. That's perimeter. Perimeter, picket fence. Area would be like the grass. And whenever we talk about area, I want you to be in the habit of shading the grass. Shade the grass. An area is, for a rectangle, is length times width. Your units for perimeter, because it is just length around it, you are in the first dimension. So your units are going to be like this: feet, meters, centimeters, miles, etc. One dimension. Area is a two-dimensional concept, length and width. So your units, feet squared, centimeters squared, meters squared, kilometers squared. So area is squared units, perimeter is singular. Let me walk you through a problem following the brain in hand techniques. Step number 1, put your finger on the paper, right there. Eyeballs, lips at the same time. Read with me with your finger following the red. The perimeter of the rectangle PQRS is 26 centimeters. The longer side PQ is 3 centimeters longer than QR. Find the area of the rectangle. That's reading number 1. Reading number 2. Find the perimeter, we're underlining keywords here, of the rectangle is PQRS is 26 centimeters. The longer side PQ is 3 centimeters longer than QR. Find the area. So what did we do here? We finger tracked and read. We filtered, and now we're going to draw, label, list, cross out. Step number 1, perimeter. We trace it, just physically trace. We're dealing with perimeter, so we go like that. We walk it around, and we're going to write down perimeter equals 26 centimeters. I have accounted for that information. I cross it out. Very important. The longer side PQ, which means I need to label this. PQ is a longer side, PQRS. Now, if I did this and put the R over here and the S over here, watch, PQRS, that's called zigzag labeling. That's incorrect. You have to go clockwise or counterclockwise. PQ, your R is here, your S is there. We're told the longer side is 3 centimeters longer than QR. Okay, I don't know QR, so I'm going to call it X. 3 longer than is plus. So this is going to be X plus 3. Always label all 4 sides. That would make this X. That would make this X plus 3. Now some of you, and we're like, you're being asked to find area. At this point, many of you kind of get stuck. It's like, I don't know what to do. I don't know what I should do to find the area. Notice the operative word is should. You ask yourself that. And if you can't say what you should do, you kind of get frozen and just stop. Forget the should question. Just ask yourself, well, what can I do? Well, let's see. Operating on that. What can I do? I could at least write down the perimeter equation, can I? I can do that. Yeah, I don't know what I'm doing with it, but I could at least write it down, right? I could at least write it down. Length plus width plus length plus width. Still don't know what I'm doing, but I mean, it mentions area. Could I at least write down the area equation? Yeah, that's easy. I don't know what I should do, but at least I can do this. You just see the process? It's a little bit different. Like, well, I don't know what I should do, but I can circle, plug, chug. Watch. Circle perimeter. Oh, there's the perimeter. I could plug it in. Equals circle length. I'm like, oh, I've got something for length. Circle. Plug it in. Circle width. I've got something for width. Plug it in. Circle length. Got something for that length too. Plug it in. Circle that W. Plug it in. By circling every aspect of the original equation, you're much less likely to make a mistake. You're like, well, still don't know what to do, but I could solve for x, can't we? Huh, let's do it. Notice I'm underlining stuff. One, underline the variables, double underline the numbers. Ta-da! I did something right. Woohoo, I solved for x. Now, if this was an algebra class, you'd kind of stop there. No, this is geometry. You never stop with the variable. You ask yourself, what is that variable? So kind of let's backtrack and figure out what is that variable. That variable x is our width. So we just found our width. And then our length, we put the 5 in here. Our length here is 8. 8. You're like, I'm looking for the area. Area is length times width. So I go like this. Circle, plug, chug again. Circle length. Pick up the length. Circle the width. Pick up the width. Notice the circle, plug, chug. Our area is going to be 40. Careful, you're not done. Our original unit here was centimeters, which means area is going to be centimeters squared. Now you're done. I'd like you to take 1 minute and summarize what are the key points of today's lesson. 1 minute, go. Writing down what are the main things you want to remember from today's lesson.